Okay, everyone, our weekly practice for the spring course is starting again. All right, this is the explanation for the first question of our first week. First, let's look at the problem. An athlete flies out horizontally from an inclined platform. Okay, here comes the projectile motion. He's performing a stunt, and the motion is assumed to be projectile motion, right? As shown in the figure, the platform's vertex O is directly above point M, right? Okay, and we also know the height h from the ground is 15 meters. Okay, an athlete is treated as a point mass, right? He flies out horizontally from point O with an initial velocity v0, which is all marked in the figure. Then he happens to hit the inclined baffle MN below the platform perpendicularly, right? Hits it exactly perpendicularly, which means, well, at this point right here, it's perpendicular, right? The direction of its velocity is perpendicular, right? This is its VT at this moment. Okay, so the inclination angle of the baffle is 45 degrees. Hey, this is 45 degrees. So this top part is 45 degrees, right? Well, since this is 45 degrees and we know this is perpendicular, doesn't that mean, well, the angle between VT and the horizontal direction is now known? Right? Ignoring air resistance, take the gravitational acceleration g as 10 meters per second squared. Okay, which of the following statements is correct? So let's take a look first. For projectile motion, we definitely need to decompose it first, right? The VT at this moment. We need to decompose it into the horizontal Vx and the vertical Vy. So Vx is V0 and Vy is, well, our GT, right? Where did that come from? Isn't it based on our formula Vt equals V0 plus At? And since it's a free fall, right, the initial velocity is 0. The acceleration is just the gravitational acceleration. So simplifying it, Vt equals a t. Since A is g, we substitute it in, and Vy is gt. Okay, similarly, our displacement xt also needs to be decomposed into horizontal displacement and vertical displacement, right? The horizontal displacement is quite simple, v0 times t, because it's uniform linear motion horizontally and free fall vertically. So isn't the formula for free fall just h equals 1/2 gt squared, right? Okay, so we first understand where the things we need to find come from. Then, well, let's look at how to calculate the four options, okay? Let's look at option A first. When the athlete hits the baffle, the ratio of the vertical velocity component to the horizontal velocity component, that is 1/2. Well, we just said here that its velocity vt at this moment makes a 45-degree angle with the horizontal direction, right? So don't we need to perform an orthogonal decomposition on it, right? Let's change the direction of this angle. If we're going to do an orthogonal decomposition, this is VT here, and we decompose it onto our x-axis and y-axis, right? Decomposing it, this is Vx here, and this side is Vy, right? Okay, we know Vx and Vy. We also know the angle with the horizontal theta is 45 degrees, right? And this is perpendicular, right? So it's an isosceles right triangle, and Vx equals Vy, right? So how could the ratio of its vertical to horizontal velocity be 1/2? It should be 1:1, right? Okay, option A is wrong. Now let's look at option B, the initial horizontal velocity of the athlete. It's 5 meters per second, so we'll have to calculate it. Okay, so what do we calculate now? We need to take our velocity and plug it back into our displacement, right? For displacement, let's look at the diagram again. The horizontal displacement is from this intersection to where we draw a vertical line, right? This is the horizontal displacement, right? And the vertical displacement, it's this upper segment, right? This is the vertical displacement. Now we have a relationship between the displacements. What is it? We know the triangle formed by M, this point, and the horizontal displacement is an isosceles right triangle, right? Perpendicular here, 45 degrees here. So this lower part is also the horizontal displacement, right? So we found that the height h is equal to our horizontal displacement plus our vertical displacement, right? So the relationship between the displacements is found. Okay, so now we just plug it in and calculate, right? Plugging it in, h is 15. For horizontal displacement, we don't know v0, right? But we just found it. v0 is equal to our vertical velocity, which is gt, right? So that's gt times t, g times t squared, right? Plus our vertical displacement, which is 1/2 gt squared, right? So 15 equals 3/2 times g, which is 10 times t squared. Let's take a moment to look at that. right? That means 10t squared equals 15 divided by 3 halves, which is times 2/3. So 10t squared equals 10, t squared equals 1, and t must be 1, right? Because t must be greater than 0, right? Okay, so we've solved it. Option C is wrong because it's not 10 seconds, right? I mean, not 2 seconds, it's 1 second, right? Then for the initial horizontal velocity, we just plug it in, 10 times 1. Similarly, it's not 5 meters per second, it's 10 meters per second, right? Option B is also wrong, right? Okay, finally, we can just calculate option D directly, right? The horizontal velocity Vx is 10 meters per second, and this is also 10 meters per second, so that's 10 root 2 meters per second. The correct option for this question is D.